This episode is produced with support from DBT Wellcome Trust India Alliance.
There's something very exciting about sea voyages, isn't there? About sailing into the vast unknowns of the ocean, especially when you're looking to unravel its mysteries armed with science. Think of HMS Beagle, the ship on which Charles Darwin, the celebrated naturalist, went around the world, researching geology, natural history, and ethnology. Or even the recent voyage of research vessel Polar Stern that was locked down in the Arctic darkness for 4 months due to COVID-19. It was part of the biggest scientific explorations to the central Arctic Ocean. Back in India, just as the second wave of COVID-19 was extracting a heavy toll on the country, a group of 22 Indian scientists found themselves on a voyage of their own out in the vast expanse of the Indian Ocean. The scientists, who are from the National Institute of Oceanography in Goa, set sail in March this year on RV Sindhu Sadhana, India's first indigenously built marine research vessel. What followed was some 10,000 nautical miles of exciting seafaring and nearly 100 days of deep water scientific exploration. In this episode of the Nature India podcast, we dive into the latest research questions that are occupying the minds of oceanographers in India and abroad. What can such expeditions tell us about the genomic diversity of the Indian Ocean? What are the trace elements present in the Indian Ocean and what can they reveal about the ocean's biochemistry? I'm your host, Subhra Priyadarshini. Stay with me for answers to some of these questions.
Once we get to know what kind of organisms, what kind of microbes are present in the Indian Ocean, it could contribute to a holistic understanding of what are the biochemical cycles that are taking place in these oceans, or how is climate change or global warming affecting the scenarios in the ocean. So if we map the genomes now and we compare it 10 or 20 years later, we could understand how climate change has actually affected the overall health of these oceans.
That's Natasha Barnes, a PhD student working at the National Institute of Oceanography. She was on the expedition where the group extracted DNA and RNA from these waters and sediments to try and map the genomic diversity of the Indian Ocean when they were back on land. The Indian Ocean is the third largest of the oceans in the world, but strangely enough, we know more about the surface of the moon than about processes at its watery depths. Eve Flancherel, an oceanographer in Imperial College London, shared some context with us.
So the Indian Ocean has been sort of chronically undersampled even more than the other regions. And so we now have a situation where we have an ocean that receives most of the pollution. That's also where most of the world population lives, right? Many billion people live around the Indian Ocean. And that's also the ocean that has essentially the least oceanographic scientific capability. And so the news that a nation like India is going to invest substantial amount of money and effort in taking a leadership role in actually driving a large-scale oceanographic program in the ocean is very good news in that regard.
It is indeed encouraging to learn of expeditions such as this recent one on RV Sindhu Sadhana. Natasha let us in on how research like this forms the basis of our future knowledge on genetic diversity of microorganisms in the Indian Ocean.
Now we have to analyze what communities are actually present in these waters. So we get purified cultures, and again we identify these cultures by the DNA sequencing. And these cultures then have various applications in industries or pharmaceuticals, because as we know, a lot of microorganisms can produce bioactive compounds, that is antibiotics. So we will now be screening these cultures for various applications.
Besides the genomic diversity, much more was studied on board as well. We asked Namandeep Singh, a senior project associate at NIO who was also on board this vessel, to fill us in.
We are involved in a lot of onboard analysis. First of all, while sampling seawater itself, we are continuously measuring the temperature, salinity, pressure, dissolved oxygen in the ocean water column with different sensors that are attached to a sampling system.
Wait. Workers are ready. Those things are not enough.
Collecting samples from the deep ocean sounds like this. We got Maite Maldonado from the University of British Columbia in Canada to break it down for us.
To give you an example, want to go down, if you want to sample water down to 4,000 meters, we use something called a rosette. This is a big frame that has like maybe 24 bottles attached to it. And you send it down. And then as the frame is coming up, you are triggering each one of those bottles to open and close at a certain depth so that you are sampling water at 4,000 meters, as you come up. So you can imagine just doing this rosette once, choose a place in the ocean, doing this once takes 4.5 hours. Just, right? So sampling the ocean is not trivial because of that depth component that we have.
The NIO team repeated this process day in and day out while they were at sea. Namandeep shared that another focus of the Indian expedition was to measure trace elements in the ocean. Now, these find their way into the ocean via continental runoffs or from the atmosphere. As the name suggests, they exist in exceedingly small concentrations in seawater. In 1 million tons of seawater, we may find around 10 to 200 grams of metal only. But listen up, because they have an outsized impact on the ocean's biochemistry.
Although they are very low in concentrations, they actively participate in different oceanic processes and therefore can be used as the proxies of these processes. And moreover, some of the trace metals can actually regulate these processes. For instance, trace metals like iron, manganese, zinc, they act as micronutrients to the marine microorganisms, and therefore they control the biological productivity and diversity of these microorganisms in the ocean water.
For example, you might think about little rocks of manganese, a metal, okay? And you probably think about rocks, but actually there are organisms that make a living by oxidizing manganese and creating these tiny manganese nodules. Or you might think about microplastics. So microplastic, you think about something very inert, you just stays there in the ocean forever. But we actually now have discovered that there are organisms in the ocean that have the ability to use carbon in microplastics as a carbon source. So they can degrade microplastics. Or we have found organisms in the deep ocean that actually can degrade petroleum, So you can imagine how these organisms are just fascinating because they might have the solution to many of the problems we have. Like, how cool will it be if you found very good degraders of microplastics? You could put them in a wastewater treatment plant and there will be no microplastic going into the ocean, right?
As Maite Maldonado points out, the potential is really mind-boggling. That's why research missions such as these are so important now. Almost 4 months after the expedition ended, the team is still doing a lot of measurements and chemical analysis.
We are really very excited. We are excited to see how the results are coming. So it will take some time, but I think I'm very hopeful that very new results, exciting results will be coming.
That's Sunil Kumar Singh, the director of the Oceanography Institute. Exciting is right. The results that they are anticipating might change the course of how we look at genomics or proteomics right now. That in itself, for each and every scientist involved in the expedition, must feel like they're on the brink of something momentous. But what was it like out in the ocean for so long? There must have been some memorable experiences.
As soon as our ship moved south of equator around about 5 to 15 degree south, the sea was very, very rough, means 30-degree rolling and pitching were there. So it was very difficult to do the sampling in that area. So somehow we managed to do some sampling, but some of the stations which we planned we could not do because the ship was so bad. Water was coming on the deck and people are not able to stand because the rolling pitching was more, so they were all the time lying. So that was a very tough time.
It was kind of scary because we didn't know whether, we would be safe or something could happen to any one of us.
As we know, during this time, a second wave of COVID hit India, and there are a lot of bad news that we were hearing during this expedition, and that has taken a lot of mental toll. But what actually keeps us going during these times that we got this a rare opportunity to work in this unexplored regions of Indian Ocean.
Overall, it was very exciting and a fun adventure, I would say, because we've learned a lot about each other, about ourselves, because that was a time we were away from all distractions, so just with our work and nature. So it was really beautiful.
That does sound beautiful. And after all, it was an opportunity to push the frontier of research in ocean sciences. The time to do that and deepen our knowledge is now. With India being a developing country still dependent on fossil fuels, the pollution and anthropogenic dust collecting in the ocean is fast growing. And we know that of all the oceans, the Indian Ocean is warming fastest. If we can better understand its processes and how they are changing, we will be better placed to protect our oceans and our planet for generations to come. I'm Subhra Priyadarshini, and this is the Nature India podcast. If you like this episode, please share it with friends and colleagues and stay tuned for new episodes in Hindi and English.
Thanks to the DBT Wellcome Trust India Alliance for their support in producing this episode.